Hi everyone, I'm Alexey Vishnyakov and I'm going to tell you about building security development in the cloud, how we solve the problem, what kind of problems we see. Maybe it will help other companies to avoid problems and maybe reduce the workload. I am head of the secure development in Yandex Cloud. I'm responsible for everything related to that. I was educated in the Moscow State University and I am a candidate of science, PhD in computer security. I'm a maintainer of outsourced instruments like Rob Gadget and Castor. We have links. You can go there and see, and I will be happy. Actually, the number of vulnerabilities grows with each passing day and year. These are the numbers of vulnerabilities. We have more and more every year. There was a report from Baghdad. It was called CIMACT before. Out of 86% of the 86 programs, they found at least one vulnerability. Secure development helps us to detect errors before deployment and avoid critical consequences for enterprises. Secure development is a standard of the industry. You saw that in Microsoft Windows XP. Actually, SDLs were there. Microsoft realized that we can do something about it and started creating reports.
Got around to this and implemented this crash report. Leaping a bit forward, the article on deduplication of crashes inspired us in our fuzzing research. Then there are other companies who started working on this. There are ISO standards, there are GOS standards in Russia. In 2024, a new standard was published in Russia for secure development, describing specific methods for analyzing code. The main idea of this presentation is to share our experience in ensuring secure development, to present some new approaches that haven't been discussed yet, and to provide some practicable advice on how to avoid errors. We'll start with the requirements, how we standardize our security pipelines, how we monitor the health of the process. We'll discuss our optimization efforts to release developers. We'll speak a bit about our research of SAST, automation of fuzzing. Closer to the end, we'll be looking at SBOMs to automate incident reporting. We'll also speak about the future at the end of the presentation. Here are the requirements as we have them in the company. There are three basic documents for this. Cloud Security Baseline. It's a list of requirement wordings. We have cloud regulations for IT security processes as applied to the cloud. And then we have the Security Cookbook. It provides technical recommendations on how to implement this through engineering. First, we have the security baseline. That's the one source for all security requirements, including secure development. It's a handy checklist for you to apply to your activities. It's structured like a standard. It has requirements, acceptable actions and recommendations, things that are not mandatory, but that improve your software security. Requirements are broken broken down into different stages: training, architecture, security, external dependencies, build, testing, deployment, vulnerability scanning, SAST, test. And we have a lot of open source softwares, and we monitor those in our cloud as well, because these are the same services that we deploy in our production. This is for your motivation. The rule of two, I borrowed it from Chromium website. That's where you can use C, C++, and other vulnerable languages. You cannot have the overlap of three, hence the rule of two. Unsecure language, untrusted user entry, and high privileges. That's a straight path to RCE. Here are some examples, pretty much copy-pasted from our security baseline. You can recognize the standards language. A developer shall do this and that. In versions control, for example, you have to have a review, the CI step. The CI has to be described as infrastructure as code and be reviewed in its turn as well. No secrets, no personal data to be included. Requirements to builds, static links, hardenings for your compilers, remove debugging information, no passwords or secrets once again. The builds shouldn't have access to the internet, and config changes shall be reviewed as well. Then there are requirements to deployment. For example, you can only deploy from release branches, not from debugging. All images should be within the cloud. Any databases or images should be mirrored, not call from Ubuntu, containerize, and all. Compliance management. We have automated checks, scans, quality gates, CI, CIEM, where we get alerts from. Then we have configuration, rules for code review, ACL, IAC. Then we have manual security audits that's applied to all new services and features. And then there are regular internal compliance audits. These are spot checks across different services to ensure compliance with the requirements that cannot be automated. Here is the composition of the audit. We have security engineers who look at the architecture, the roles, the data flows, threat modeling, as we've heard today. We do it in a simpler way, something more akin to Stride, and our models are standardized. Identification of the attack surface, and fuzzing functions. There is a manual code review, pull requests, diffs, a bit of manual work. At the end, you formalize an observations list, changes to be implemented. It's done through iterations, and at some point, the feature is approved for public release. Our company uses different analyzers. We use SAST for our own code. We use SCA for external dependencies. We do fuzzing. We form software bills of materials. And here is the pipeline. We have voting builds, release builds. The events are twofold, either on release or every night. It triggers SAST, SCA, fuzzing, all passing through quality gates. By quality, it means security here. Then we have bombs for release builds. Artifacts are signed to be added to software bills. All of those pipelines need to be standardized and centralized so that different services do not become a mixed bag. We have centralized scripts for SBOMs, for gates, or initiation of tools. There are standardized artifact collection forms, which gives us the centralization that is needed to run our pipelines. This reduces the load on operations. We don't have a diverse mix of scripts. There is a single source of truth. All the amendments are introduced through there. Then you have templates for new services to initiate them. The process thus becomes predictable because we have the scripts on hand and we have developed them. And this centralizes security of changes as well. Again, it's a one-stop shop solution in a way. Then you have to constantly monitor the health of this process. Technical operability is included into here as well as quality gates to make sure that all services comply with security requirements. You can plot trends based on this data, number of alerts or triggers per week, per month. You look at the backlog of alerts in SAST and SCA in fuzzing, compliance with licensing, and compliance with quality gates. We have a threshold for criticality, and you have to be below it. It can vary based on the application business or security. We check the workability of each step in the pipelines. We do track the false positives, and we look at the monthly and weekly stats for alerts. Here is how we implemented this. Data Lens is our own cloud service. There is a dashboard for this that displays the metrics. It does snapshots of states daily. We have engineer on duty who looks at the dashboard, looks at the builds, fixes something that's needed or taps the service. There is the vulnerability manager separately as well who looks at the vulnerability and pushes the people who are responsible for tickets. Once we have a dashboard, it was quite obvious to use it to optimize SAST. If you have too many alerts that are not relevant and it's fuzzy or false positive, then it annoys people, annoys developers, and reduces trust. We want to alleviate their workload while maintaining the quality of detection. We've disabled some SAST checkers. Dashboard for false positive per checker. We've looked at the worst offenders. We disabled most of code quality checkers. We've removed reduplication of alerts. But then you still have to always have security checkers. If it's for injection, it can have a higher rate of false positives, but then if it catches something, it's very important. You can refer to the Russian cost standard for security development. It has a list of critical checkers that have to be always on. To the left is our stats before the checker exercise. To the right is half a year after. Our true positive is up from 30 to 61%, and the total number of alerts is lower. It used to be at around 33,000, now it's 7,500. So, quality up, workload for developers down. It's not as easy to calculate the fix time, but you can calculate triaging. So if it's 15 minutes per ticket, so it's down from 6 to 2 FTEs. We are researching open source statistic analyzers. We want to migrate from heavy-handed enterprise solutions to open source. We want to have more control in SSDLC, as we can dig into the code. It's not a black box. We want to keep up with new versions of programming languages. We are keen on cutting-edge toolchains, compilers, and standards at Yandex. Open source usually moves quicker, and they keep in lockstep with the most recent standards. And then again, some vendors are no longer available, so you have to look for alternatives. Our challenges include the diversity of the stack. We have Go, Java, CC, TypeScript, so not all SAST can compile this out of the box, and this can be additional development effort. Be ready, you wouldn't be able to cover all languages within one SAST analyzer, and you'll have different ones. Our code base in the repository is really large. Some projects have dependencies tying it to like half of the repository, and the analyzer must be able to handle that. Here are our criteria for selecting SAST analyzers. The quality should be on par with what we have. It needs to be able to do cross-validation with other analyzers, and we look at the maintainers. Microsoft, FANG, has to have a community around it with active contributors, a lot of commits, implementations, stars. Then we cross-check it with our Russian cost standard. It has to support the prescribed list of checkers. It's always useful when it supports serif standard, so you can integrate different analyzers and output it into a single web interface. It has to be compatible with our existing compiling infrastructure as well. We've reviewed this for the language Go, GoSec and static check. These two are complementary. GoSec focuses on vulnerabilities, static check focuses on quality, but it's useful for compliance with Russian standard. You can expand it with some additional checkers, and this will give you a full coverage. They all support serif, and they can be ran through lint. Our preferences can shift, so we are looking at multi-language SASTs, CodeQL, sysgrab. It seems to be useful to combine them with sysgrab or hotql, for example, where you have a set of rules to look for vulnerabilities. There is Infor as well. It can do Java and C++. We're executing the code. Code checker is also nice. It's available from Ericsson on GitHub. It integrates execution of various useful analyzers or checkers. As a platform, it has a nice web interface. You can do markup there for the results, so it can be easily integrated with different statistical tools. We are studying SonarQube, but the paywall is pretty high, and the freeware version is not as capable, so it's probably a no-go. C++ has Cloud Tidy, Cloud Tidy Analyzer. It sounds like a linter, but it includes simple checkers as well, that you don't have a class static analyzer that's for more complex vulnerabilities. It has intermodule and interprocedural analysis, runtime, and other nice features. Integrates nicely with hot checker, code checker, does aggregation and markup. Not as rosy for Java, spot bugs, SAST.
Все выглядит не очень радужно, именно по специфичным
So,
возможно, там для Java надо
when we speak in specific analyzers, it's not as great. Maybe Infer CodeQL is better for Java, a multi-language tool. Specific to JavaScript or TypeScript, we have currently just one option, ESLint plugin security. There is a limited set of rules that you can use. And then, of course, you can apply CodeQL samgrep for this as well. And now on to fuzzing. Any fuzzing starts with the attack surface. The audit reveals the dependencies from the attack surface to the functionality. Functions need to be accessible through an external interface, not necessarily directly. Parsing of input data, and priority increases if it's more easily reachable from the surface. So we use gRPC in the cloud, and that's the high-level interface for us, where we do fuzzing. Archival library is buried much deeper. It's not as high as a priority, but we still do this in terms of reachability. You can do grep by keywords, parse, load, import, read. You look for format parsers. If the function can take a buffer, it's better than complex objects that need to be initialized. And, well, you'd be aware of OSS fuzz if you're doing this. It has a lot of packages, different shells. So you can make use of it. We have two approaches to fuzzing. We can fuzz gRPC handles. We use structure-aware fuzzing and protobuf mutator, where we generate input data and fuzz the surface. It's labor-intensive, but it's really effective. Then we do fuzzing for specific functions. It's a deeper exercise. We can find some bugs with that, but we usually do a combination of two. Here is what we are preparing for publication. We are cleaning it up technically. We haven't been able to do this for PhD. We've developed a mutator analog for Go. LLM fuzzer test on input is a classical function. Proto messages are passed to fuzz. It's not even on the screen. It's a large handle, self-generated code with a lot of pass-through. There is the custom mutator who calls up a library. It mutates the input data to generate new sets. Here is our fuzzing pipeline. We compile the goals or the targets. It's stored as free to replicate crashes. We download the set, minimize it, or the corpus. We fuzz it. We store it at S3 in logs. If there are crashes, we deduplicate them. I'll show this a bit later. So we only store new crashes relative to the reports that we already have in S3. This generates tickets for developers. We monitor coverage as well. Fuzzing is configurable. It's in the code almost. Test target, ticket addressing, and then we have crash analysis and severity report. It's an open source tool, Casper, that generates a report or crashes and deduplicates them. So that's what the report looks like. the section of the code, type of error, probability. It supports various programming languages and fuzzers. There was a report a couple of years back at Ozone. There is a deep dive into that. So you can use it as well. Deduplication of crashes. We have Casper or Fuzzer as a tool. You run a session and it deduplicates crashes within one run. Reports have stack traces in JSON format. You download previous reports from S3, you call the diff cluster. It re-uploads back to S3 just the new reports. It's a simple diff based on stack trace. We filter out sanitizers, abors, and other not needed functions, and we make a basic comparison for equivalency. There are approaches where it's clustered, but this bare bones approach seems to work for us. We don't have excessive tickets. Here is a bit of a know-how that we have, how we use SBOMs for CIEM. We have a lot of servers that are being deployed at all times. We want to know what their components are, who built them. Here are two cases. Let's say there is a login library that all services are using. There is a vulnerability. All services have replicated it. We see that services have deployed it as well, and they need to redeploy because the shared library was vulnerable. Or maybe there is log4j, some other big news, and you need to see what services in production have been affected. We have specific alerts in CIEM. We have files in CI/CD. Developers do not bring in binary code from their personal laptops. We have deploy policies to prevent it from debugging pipelines or personal branches. We scan vulnerabilities ad hoc in production on top of SSDLC, and we are trying to automate security incident investigations. That's for production, just for the case that I've just laid out. A service built and deployed with a vulnerable library. We are enriching BOMs with Java and Python. It's sent to CIEM, and SOC analysts can use them for investigations and additional data source. Composition analysis is done on build level, but we are trying to develop alerts in CIEM for this as well. We have OS query for file hashes, but we want to migrate to a higher performing tool. We are also developing SBOM generation for C++ based on the repository data. There are hints there for components, there are versions, and the repository has this in it as well, especially for third-party components. Well, we've seen a software bill of materials. It's a JSON. It lists the components. Anything can be a component. The example shows a microservice. It's something in the cloud. It has a component from the library. The library is files, the source code, and it has the hash. CycloneDX from GitHub provides you these BOMs, but we need to enrich it. It's not as informative. The number of the commit, the build parameters, reference to the build, the packages as artifacts, versions of hash files, the same for Docker containers, including tags and so on. BCS info can be written down as a pedigree, which is very convenient in SBOM. If it doesn't fit in Cyclone DX, you have a random feed under properties, so you can state the development branch and so on. For their packages, we look at the packages that you have within the build. We have hashes, enter this into the bill of materials. A bit more complex for Docker. Dive is a bit too heavy. We decided to develop our own code for this. You run Docker events. It has JSON format. It saves all the events. It sees the images, which constitute the artifacts of the build. We look at the pools. The hashes are provided elsewhere, so we do not go there. We save the layers, do hashing for internal files, add this to the bill of materials. Hash of layers, match ID, internals of files, and hashes. We have all the intellects through hash files. We generate and enrich SBOM. It's all uploaded to this special SBOM storage. The to be is to have drag on. So we can only use hash files, cross-check. If it's not present, this file was not compiled or built in CI, so something alien is in production, it's an alert. We are developing the other part, where this can initiate vulnerability scanning, so that it can issue alerts in CIEM for critical vulnerabilities. Then there are user lookups on demand. SOC analysts can get a display, for example. Show me a list of all production components that were compiled from this or use that. A bit of forward-looking words. We are all implementing AI into security development. It has been ad hoc scripts, some manual development. Maybe there are going to be tools sooner or later. We use AI in 3 areas at this time. Automated triaging. You can compare SAST and SCA output with what LLM gives you. It can explain the errors. Sometimes it indicates a specific area of code to be fixed. The second application is reachability analysis, pretty much like the first point, but this is for reachability, where an LLM can indicate the section of the code where that library is pulled, so that the analyst can find this easier and evaluate the criticality. Our processes first give this to OPSEC. They prioritize the criticality based on reachability. Then it goes as a ticket to the service with the criticality stated. We have a code assistant in SourceCraft. It generates fuzzing targets. It works with simpler languages like C. More complex languages are not as accessible, but LLMs are advancing, so we'll see. Some other things to keep in mind for the future. We want to be vendor independent in SSLDLC. We are looking at open source solutions. We develop our own things. We try to be part of the community. Come with pull requests. We want to scan IAC deploys because there are opportunities for statistic analysis. We are looking forward to getting SourceCraft internally to be integrated with CIEM, so that we can get events from there, SOC alerts, let's say review rules have changed, new admin has been added to a repository. This would generate useful alerts for our PCS. We continue developing SBOMs. We want to have a fully fledged asset management there, to have visibility of the entire landscape, all our services, how they were deployed, their stage in the life cycle, their vulnerabilities. This would be a centralized storage for everything that we have in production. With that, thank you. I was glad to share this with you. I have a QR code to score my speech. I'll be taking your questions now. 2 mics in the aisles, and the best question will get a book. Great. That was my announcement. So thank you.
Здравствуйте. Подскажите, пожалуйста, спасибо за доклад. Подскажите,
Hello, thank you for your presentation. What's your fuzzing strategy? It takes some time, takes a while. Do you run it for each build? Or is it once per night or some other schedule? It's the same strategy as everything, on release or every night. That's what we have so far. So a developer cannot make sure that their commit doesn't break anything until it's dark, until it's after hours. No, we don't have quick fuzzing for commits. We plan to implement it, but these quick fuzz runs do not happen for pull requests.
У меня на самом деле очень похожий вопрос был.
I have a very similar question. Let me rephrase this on the go.
Вы используете для того, чтобы
Do you have any tools
с учетом вот этой синхронности запуска инструментов
based on the schedule,
изменения,
tools to determine specific changes and commits that have led to errors?
целые пачки коммитов
You
получаете?
analyze entire batches of pull requests and commits, right? Do you then pinpoint specific offenders?
Про все сразу. И
This is a question about fuzzing, right? Fuzzing, SAST, what have you. Analyzers.
Вот, там можно посмотреть, где происходил крэш. Это не автоматизировано, это ручное.
It's not automated. You can look it up. The ticket will contain part of code. You can click into it and do blame.
То есть тут
Think it's a pathway, but it's manual.
для фазинга представляет 100 кусок кода, но то же самое для SAST.
And in fuzzing, it's the same as SAST.
Это наводку поддается
Code snippet.
инженеру, который триажил, то есть сам
SCA,
куски кода. Если
the tool doesn't have it.
ткнет разработчика,
It's down to triage. If the OPSEC is diligent, they would specify some part of the code to the developer or can blame the entire library.
у Гугла
What I'm getting at is that Google's cluster fuzz has some functionality for this. They try to pinpoint it down to a commit. Think you could look into that.
в сторону
Or
анализа по коммитам.
try and
Благо, что у вас под рукой
leapfrog to commit-based analysis. You have your own infrastructure, a lot of computing power, so you can afford that. BCM and fuzzing in cluster files, yeah, I know it's a good idea. It can be implemented, we don't have it. Our tests can be complex and can take a long time. So it can take an hour for tests
Да, понятно.
after a single commit. So bisection is a pain point for us. Okay, my second question.
С учетом, вот опять же, аналогии между, скажем, Гуглом и
So,
вами,
to continue with this parallel, yourself and Google,
свой аналог
do you have plans
OSS-фазы,
to launch
опять же, с учетом
something
того, что
similar
у
to
вас,
cluster
под рукой
fuzz or OSS fuzz? Again, you have the compute, you have the cloud.
Пошли по более простому подходу, то есть до этого
We went for a simpler approach.
как раз тем, что делал что-то больше.
At my previous jobs,
Здесь мы пришли к более
I was responsible for things that are more similar to OSS fuzz. Here, we focus on security. There is no
грубо говоря, вот то, что
JIT infrastructure.
показывал, вот этот пайплайн файзинга, это, не знаю, там
This
пару
pipeline,
на питоне. грубо говоря.
this is a couple of thousand lines of Python.
Что тебе нужно в узкой специфике в
If you know
компании, ты можешь
what you need
файзинга на самом
in a
деле
narrower scope within your company,
будет проверять
your fuzzing pipeline can be much simpler,
тебе не
and it'll be tailored to the code that you are developing. You won't need this
иметь сложный агрегат, который там периодически там
complex machine.
ты плюс-минус можешь себе позволить в обычном CI это все гонять.
You can do this within CI.
Ну, это
if you're confined like this. Point taken, but on the other hand, cluster and OSS fuzz are there for a reason. If you consider that maybe to come up with something similar so that there is no monopoly in the market to compete with Google. We don't have plans like this, but it's an organizational concept. Google invests into security of OSS components. They provide compute to do fuzzing. I think that's what they're doing. So open source developers use that. It's a one-stop shop. I'm not sure it's reasonable to give another alternative. If we don't trust them, we have a centralized thing. They burn their own electricity for this. Well, I wouldn't count on them. And it's great that you want to become vendor independent. But then again, any competition is far better than just one sole monopoly vendor. Last quick question. You mentioned SAST. What about fuzzing engines? Which ones do you use? LibFuzzer mostly, due to replicability and stability. We have C++, but these are ad hoc. We want fuzzing targets and goals to be stable and similar for different languages. Stability is key here, and it outweighs in terms of defense, not as attack. i5++ is better for you as an attacker, but for us as the defending side, the other solution is better. Hello, my name is Mikhail. Thank you for the presentation. I got curious about this vendor independence in SAST, your migration to open source analyzers. Have you done the estimates for the economics there? People say that open source is not as cheap to be implemented in a company. It requires a lot of reworks and improvements. Adding rules, for example, because free rules are few and far between, and the quality leaves to be desired. Yes, I mentioned this, but enterprise solutions require additional work as well, and it's more challenging. The concept is that it's okay to send pull requests to GitHub, but then in a proprietary solution, it's not easy to go through the bug pipeline. They fix bugs at their own volition. So we've experienced more pain from enterprise solution, and we do a lot of workarounds on our side there. And in the open source case, we would be able to edit the tool itself. Open source is on the rise. CodeQH is making strides. It can do builds, different languages, something to look at. Analyzers for C++, they're quite powerful as well, and they are compliant with the Russian standard. Then they have code checker, triage and markup interfaces. So the outlook is positive. And we consider our own internal tool as a product as well. Have you considered developing your own open source SAST analyzer to make it available to our community? It doesn't make much sense. The level of developer there is on the compiler developer level. You can count all engineers like that in Russia with two hands. It'll be really hard to hire the resources for that. So it's not feasible. And there is an open source open source tool is being developed, you can contribute. We have a whole maintainer at Yandex of Clan Static Analyzer. They can develop a checker. That's what we're doing. Just like the previous presentation, you shouldn't compete in open source. You should all invest in good centralized solutions. Well, that's if they accept pull requests from Russia. But we have a maintainer. Okay, one last question. Hello, thank you for the presentation. My name is Evgeny. In CI, you mentioned builds that do not have access to the internet. How do you enrich this with the libraries? Do you have any pre-checks before libraries get inside? We have IP tables where they can only call eternal hosts. And then you have a registry within the perimeter. There is a tool by people for server infrastructure. As we download something to our internal repositories, they check for signatures, authenticity. We have a quarantine for Java. If there is a new dependency, you cannot use it for 2 weeks. It will not be downloaded. So there are defenses like that.
Спасибо.
Thank you.
Спасибо. Ты хочешь еще вопрос?
Thank you. Another question, if I may? A quick one. Looking at that slide, I thought of another question. Who develops shells or packages for fuzzing testing in your company? I looked at a Google presentation on cluster fuzz, and they boasted with their team being just 5 people strong to maintain their fuzzer. Yeah, I talked to them. They suffer there being understaffed like this. On our side, we have salaried developers to do this. We just give them the tasks. If someone doesn't know what that is, we schedule calls, show them around, explain what it is, but they develop it on their own in their teams. Okay, good. Thank you. So for the most challenging part, the most challenging question, pick the best question. I like this one about from the guy in the orange short. Okay, please come up and get your book. Thank you.